is happy because that has 8 electrons. This fellow is crying. Why this fellow is crying, sir?
Incomplete octet.
According to octet, everybody should have octet of electrons to get stability. Central fellow is having only 6. Now, in order to make this fellow also happy, I can convert any one lone pair, either this or this, any one at a time, as a double bond. For example, if I use this, now I will write a structure like this. This will have, this is converted into bond pair. Therefore, it has only 2 lone pairs now. It already has 1 lone pair. This is a bond pair. This has 3 lone pairs. I can write a structure like this. If I write like this, now this fellow is happy. This fellow is also happy. This fellow is also happy. I have converted either this lone pair or I can convert this lone pair into bond pair. So I can write a structure like this. See, observe. It has 3 lone pairs. It has 1 lone pair. It has 2 lone pairs. Or I can write the same as this. Then it will have 3 lone pairs. It will have 1 lone pair. It has 2 lone pairs. Both are equally likely. They are called resonance canonical forms. Okay, sir? The real structure of ozone is really not 1, not 2. It is in between these 2. I would say that the real structure of ozone is something like this. This is having either a double bond here or a double bond here. Anyway, let us not worry about that. Let us look at this form of structure. If I take this as final structure, it is first oxygen, it is second oxygen, it is third oxygen. Okay, sir? Some students have joined right now, and now there will be confusion to students who joined right now. So if you permit me, I want to repeat what I said. Should I repeat, sir?
Yes, sir.
Very quickly,
Yes.
very quickly.
Yes, sir.
For the benefit of those fellows who joined just now, I am repeating. Question is, write Lewis dot formula for ozone. Find formal charge on each atom is our question. We are trying to address this question. To write the Lewis dot formula, I should know that each oxygen has how many valence electrons? Each oxygen has 6 valence electrons, 2s to 2p4. So 3 oxygens have 3 into 6, 18 valence electrons. Now, in order to accommodate these 18 valence electrons, I will write O3 like this. To each central atom, I make at least 1 bond pair. Out of 18, I used 4. Out of 18, I used 4 means still there are 14. The 14 I distribute on terminal oxygen so that everybody gets octet. So I write 6 here. Now it got 8. And I write here another 6. Even it got 8. So out of 14, I used 12 electrons. Remaining 2 I put here. When I write like this oxygen is happy as it got octet. This oxygen is happy as it got octet. But this oxygen is not happy because it got only 6. In order to see that everybody gets octet, I can convert any one electron pair, either this or this, any one into bond pair. If I convert this into bond pair, the structure of ozone would become now like this. It will have 2 bond pairs and it has 1 bond pair and it has usual 1 lone pair. The terminal oxygen has 2 lone pairs. This fellow has 3 lone pairs. You know how to write up to this. If you write like this can also be represented like O double bond O, single bond O, and it has two lone pairs, it has one lone pair, it has three lone pairs. Now in this structure, it is first oxygen, it is second oxygen, it is third oxygen. Sir, you will be wondering why you wrote double bond here only. Can you write this side? Yes, you can write this side also. You can write like this also. You can write like this also. Then it has two lone pairs, it has three lone pairs, it has one. So you can write a structure like this, or you can write a structure like this. The real structure is a hybrid of these two. These two are called canonical forms. The structure can be like this or like this. The real structure can be written like this. Anyway, if you write like this, the formal charge on first oxygen, second oxygen, third oxygen, we calculate. Formal charge is equal to expected valence electrons of oxygen minus available electrons in valence shell. How many electrons are available? First oxygen has here one electron pair, here one electron pair, here. There are three lone pairs, means 6 electrons, plus there is one bond pair. One bond pair means 2 into 1 by 2 belongs to this oxygen. That is equal to 6 minus 7. The formal charge on first oxygen is minus 1. Let us work out the formal charge on the central oxygen. Formal charge is equal to number of valence electrons expected minus available electrons. It has one lone pair means 2, plus it has 3 bond pairs, 1 here, 2 here. 3 bond pair means 6 into half, because in bond pair only half of it belongs to this oxygen. So it is 6 minus 5, that is equal to plus 1. The formal charge on central oxygen is plus 1. Let us look at this terminal oxygen. This terminal oxygen has expected electrons 6 minus, it has one lone pair 2, plus it has two lone pairs, right? Two lone pairs means 4, plus it has two bond pairs. Two bond pair means half into 4. That is equal to 6 minus 6, 0. So the formal charge on this terminal oxygen is 0. So the ozone molecule has first oxygen with minus 1 charge, second oxygen with plus 1 charge, third oxygen with 0 charge. In ozone molecule, 2 oxygen atoms have formal charge, plus 1 and minus 1. Any structure that has formal charges is not very stable. So ozone is not very stable. Let us look at oxygen, for example. Oxygen has 12 valence electrons. I write oxygen like this. I put 1 electron pair. Out of 12, if I use 2, 10 are remaining. If 10 are remaining, I will write 10 as 2, 4, 6, 8, 10. If I look here, this is happy 8 electrons. This is not happy 6 electrons. To make this fellow also happy, what I do is I convert one of the lone pairs into bond pair. So if I convert this, this got 8 happy, this got 8 happy. Therefore, the structure of oxygen is O double bond O, 2 lone pairs, 2 lone pairs. In
Hello.
O2, if I look at formal charge on this oxygen, the formal charge on this oxygen is equal to expected electrons minus available electrons. 2 lone pairs means 4, plus 2 bond pairs means 4 into half. 6 minus 6 is 0. Formal charge on this oxygen is 0. Similarly, formal charge on this oxygen is also 0. In oxygen O2, O double bond O, each oxygen is making 2 bonds and it has 2 lone pairs. Formal charge is 0. If formal charge on all the atoms is 0 in a molecule, that is very stable. So O2 is stable. Whereas O3 is not very stable. O3 is not very stable because here one oxygen has formal charge -1 and one oxygen has formal charge. How much, sir?
Plus
+1.
+1, and one oxygen has formal charge 0.
0.
Right? Therefore, ozone
No.
is not particularly stable because one oxygen has formal charge 0, one oxygen has formal charge +1, one oxygen has formal charge -1. Ozone is not very stable. Can you write Lewis dot formula for carbonate ion? For carbonate ion, there is a carbon which has 4 valence electrons, 1s2, 2s2, 2p2. 3 oxygens have 3, 6 or 18 valence electrons. Extra it has 2 minus charge. So extra electrons are 2. Total it has 24 electrons. How to adjust 24 electrons in carbonate? There is one carbon which is central atom. There are 3 oxygens. First I write 1 electron pair between each 2 atoms. 2, 4, 6. Out of 24 I used 6 means 18 are remaining. The 18 I distribute on terminal oxygens. 2, 4, 6. This oxygen is happy. 8, 10, 12. This oxygen is happy. 14, 16, 18. Every oxygen is happy because it got octet. But carbon is unhappy because it has only 6. So any one lone pair, either this or this or this, any one lone pair I can convert into bond pair. For example, I can write a structure like this: C double bond O, 2 lone pairs, single bond O, 3 lone pairs, single bond O, 3 lone pairs. If I write like this, I can see that this oxygen has a formal charge 0. You can see expected electrons 6 minus available electrons 2 lone pairs 4 and 2 bond pairs 4 into 1 by 2. Its formal charge is 0. The formal charge on carbon, expected electrons are 4, available are, there are 1, 2, 3, 4 bond pairs, 8 into 1 by 2, 4. Expected are 4, available are 4, so formal charge is 0. But for this oxygen, expected is 6, available is 7, because there are 3 lone pairs. 3 lone pairs means 3 twos are 6. 1 bond pair means 2 into 1 by 2 is 1. So available electrons are 7 means its formal charge is -1. This oxygen formal charge is also -1. In carbonate, I can write one structure like this. But I can also write double bond here. Double bond O, single bond O, single bond O. If I write like this, this will have 2 lone pairs. It will have 3 lone pairs. It will have 3 lone pairs. I can also write one more structure, double bond here. So there are 3 ways to write carbonate. The real structure of carbonate is a resonance hybrid of ABC. And in any of these structures, one oxygen which has double bond and 2 lone pairs has 0 formal charge. The other oxygens which are making 1 bond and 3 lone pairs have -1 formal charge. The carbon has 0 formal charge. Okay. This is the way to write the Lewis dot formula for carbonate ion. Have you seen, sir, carbonate ion? Hello,
Yes, sir.
have you seen? Now there is a challenging question. Can you write Lewis dot formula for no nitric oxide? Well, nitrogen has 5 valence electrons. Its configuration 1s2, 2s2, 2p3. Oxygen has 6 valence electrons. Its configuration 1s2, 2s2, 2p4. Total, it has 11 electrons. Now, between nitrogen and oxygen, you can write one lone pair. And you should make oxygen happy because that is more electronegative by putting 3 lone pairs. Now it got octet. Now, out of 11 electrons, you have used 8. Now 3 are remaining. So write 3 like this. If you look at this, oxygen is definitely happy because it has 8 electrons. Nitrogen is not happy because it has 5 electrons. To make it happy, you can convert one lone pair into extra bond pair. You can write like this. Again, oxygen is happy, but nitrogen is still unhappy. It has 7 electrons. You can't do anything. Notice that the nitrogen has only 7 electrons and oxygen has 8 electrons. There is no other way to make any other adjustment. Okay. Okay, sir. Therefore, this is called as an odd electron molecule. Hello. Hello?
ఆలోచించావు 10 సార్లు చెప్పిందే చెప్తావు 10 సార్లు మాట్లాడితే మాట్లాడతావు
Therefore, I don't know, somebody made a wrong phone call and they are talking with themselves. Well, nitric oxide is an odd electron molecule. It is not obeying octet rule. There is no way to write nitric oxide in any other way. So this is the Lewis dot formula. The formal charge on nitrogen in this structure is nitrogen is supposed to have 5 electrons in the valence shell minus. It has how many? It has 2 bond pairs, means 4 into 1 by 2. Plus it has 3 electrons. So formal charge on nitrogen is 0. Formal charge on oxygen is also 0. But nitrogen is not getting 8 electrons. It gets only 7. It is called odd electron molecule. Not only NO, NO2 is also a odd electron molecule. So it means that there are some molecules which are not obeying octet rule. Very clear. Also, if you look at beryllium chloride, beryllium is using only 2 electrons to make 2 bonds, BeCl2. It means in BeCl2, if you write the Lewis dot formula, beryllium has 2 valence electron, each Cl has 7 valence electrons, 14. Out of 14, you used 4. So, remaining 10, you distribute like this. 6. Each Cl has how many electrons, sir? 7. 7, 2s are 14. Beryllium has 2, total 16. Out of 16, here you used 4, now you used 6, here you use 6. So in BeCl2, Cl is happy, but beryllium is not happy because it got only 4 electrons. See, molecules where central atom is not getting 8 electrons, it is getting less than 8 electrons. In BeCl2, beryllium got 4. In BeCl3, boron got only 6. These molecules where central atom is getting less than 8 electrons, namely BeCl2, BeCl3, LiCl, they are called electron deficient molecules. So octet rule is not followed in some electron deficient molecules like LiCl, BeCl2, BeCl3, AlCl3, etc. It means octet rule and Lewis concept is not universal. There are deviations. Also, I want you to kindly look at a molecule like this, PCl5. In PCl5, phosphorus is bound to 5 Cls, where the phosphorus is getting 10 electrons. In SF6, sulfur is bound to 6 fluorines, where sulfur is getting 12 electrons. In IF7, 1, 2, 3, 4, 5, 6, 7. In IF7, iodine is getting 14 electrons. So there are many molecules where central atom is getting more than 8 electrons. Therefore, these molecules are called electron excess molecules. BeCl2, AlCl3, where central atom is getting less than 8 electrons, are called electron deficient molecules. Therefore, Lewis dot formula and octet rule are not followed in many cases. And also the Lewis dot formula octet rule cannot explain the shape of molecule. In chemistry, shape is very important, sir. Even in Allah creation, in your hand, all the 5 fingers don't have same length. Have you observed? Look at your hand. Do all 5 fingers have same length? No. There is intelligence in this design. Only the hand, if it is like this, then only you can have good grip. Allah is not unintelligent. He has designed your hand like this. In the Allah design, there is a lot of meaning. Both of your legs have equal length. If Allah created one leg longer, one leg shorter, you can't run or you can't walk. In our body, the design has a lot of meaning. 2 eyes are located like that so that you can have a 3D view. If the eyes are not designed like this, you can't see properly. Therefore, in chemistry also, shape of molecule has a lot of meaning, lot of significance. But our Lewis dot formula octet rule cannot say anything about shape of molecules. So what are the defects of Lewis dot formula and octet rule? A, there are so many molecules where the central atom has either less than 8 electrons or more than 8 electrons. B, the Lewis dot formula cannot tell anything about shape of molecule. C, the Lewis dot formula cannot say anything about energy of molecule. D, the Lewis dot formula cannot explain why in a double bond, sigma bond is stronger, pi bond is weaker. Therefore, the Lewis dot formula and octet rule are not sufficient to understand covalent bond. You already know that ionic bond is formed due to transfer of electrons. Ionic bond is formed between a metal and a non-metal. Generally, in ionic bond, metals lose electron, non-metals gain electron. Boss, I'm in class. I'll call you after some time. Okay. Therefore, ionic compounds are crystalline solids. They have high melting point. They dissolve in polar solvents like water. Ionic bond is non-directional. Reactions between ions are very, very fast. And ionic compounds have good conductance. All this we have learned. Yes, sir. Hello, are you there?
Yes, sir.
Are you there?
Yes, sir.
Yeah, I'm more worried. So ionic compounds have some properties, whereas covalent compounds can be gases, they can be liquids. Covalent bond is formed by sharing electron pairs. A covalent bond is formed between identical atoms or atoms whose electronegativity difference is less than 1.7. And covalent compounds usually dissolve in non-polar solvents like benzene, carbon tetrachloride. Reactions between covalent molecules are usually slow. Covalent bond is different from ionic bond. We have learned up to this point. Now, in a covalent bond has a direction. In ionic bond, there is no direction. In covalent bond, there is a definite distance between bonded atoms. This is called bond length. Sometimes you require some energy to break a bond. The energy required to break all the bonds in 1 mole of molecules like H2 is called bond enthalpy. If you look at molecules like H2O, CH4, the angle between the bonded atom and the central atoms is called bond angle. Therefore, in a covalent bond, you have something like bond length, bond angle, bond enthalpy, etc. These are called bond parameters. Notice that a covalent bond is formed by sharing of electron pairs. Maybe one electron pair single bond. If two electron pairs are shared a double bond. If three electron pairs are shared triple bond. Therefore, there are broadly two types of bonds: ionic or electrovalent bond, covalent bond. Ionic bond involve loss and gain of electrons, formation of ions. Covalent bond involves sharing of electron pairs. Ionic bond is formed between a metal and a non-metal. Covalent bond is formed between identical atoms and non-metals. So, this is a broad outline of covalent bond. Let us try to look at what our NCERT book says on this. Very quickly, we look at the NCERT book at this point of time. We are looking at NCERT book. Yes. Sir, this is what NCERT book says. How to write Lewis dot formula? You need to practice writing Lewis dot formula for molecules like Cl2, H2O, CO2, C2H4, N2, C2H2, etc. Also practice writing H2O2, O3, NF3, carbonate ion, HNO3. What are the rules to write the Lewis dot formula are given here? You have to read them. And also, examples are given in the textbook. Write the Lewis dot structure for CO, Lewis dot formula for NO2 minus, for formal charge, how to calculate. I gave a shortcut way. Formal charge is equal to expected electrons minus available electrons. Expected electrons means total valence electrons in free atom minus available electrons means number of electrons in lone pairs plus half of the number of electrons in bond pairs. How it is applied for ozone and the limitations of octet rule. Examples for molecules where there is less than 8 electrons, odd electron molecules, expanded octet, and the drawbacks of octet theory. Also, in ionic compound, there is somebody who is losing electron making a positive ion. There is somebody who is gaining electron making a negative ion. Every positive ion is surrounded by a definite number of negative ions. Every negative ion is surrounded by a definite number of positive ions called coordination number. The structure of the sodium chloride is called face-centered cube. How this face-centered cube looks like? Red dot is sodium ion, bigger blue dot is your chloride ion. Always positive ions are small, negative ions are big. Whenever 1 mole of oppositely charged gaseous ions come together to make solid crystal, energy released is called a lattice energy. For NaCl, lattice energy is minus 788 kilojoules. Lattice energy can also be defined as the amount of energy required to break down a solid crystal completely into gaseous ions is called lattice energy. If you are defining energy required to break, it is positive. If you are defining the energy released when gaseous ions are coming to make solid, it has negative sign. Always remember, lattice energy should have negative sign. It is the energy released. Here is a definition of lattice enthalpy. Bond parameters are there for covalent bond. What is bond length? Single bond is always longer. Double bond is shorter. Triple bond is shortest. Double bond means 2 electron pair share. Triple bond means 3 electron pair share. Bond length is measured in nanometers or angstroms or picometers. Here is the definition of bond length. Half the internuclear distance between two bonded atoms. Also look at bond angle. Angle subtended between bonded atoms to central atom. Bond enthalpy means energy required to break 1 mole of bonds between atoms in a molecule. How the bond length is values. The shortest bond length is there in F2. As the sizes of the atoms are increasing, bond length increases. Look at the data related to bond lengths. Half of the bond length is called covalent radius. Look at the covalent radii. Also, If you have a molecule like H2O, the energy required to break the bonds, first OH bond, next OH bond. Average of these two is called average bond enthalpy, or mean or average bond enthalpy. Total number of bonds broke, energy required to break down all the bonds divided by number of bonds broken. Bond order means in Lewis' description of covalent bond order is given by number of bonds between two atoms. Between two hydrogen atoms, there is only one bond order is 1. Between two oxygen atoms, there are 2 bonds, bond order is 2. Between two nitrogen atoms, there are 3 bonds, bond order is 3. As bond order is increasing, the energy required to break the bonds, that is bond enthalpy, will increase. N2 has highest bond order, highest bond enthalpy. Okay. So I want to speak more about bond order for your NEET exam tomorrow. But this is what that they gave in the textbook. If you cannot write one single structure for a given molecule like O3, like carbonate, you write several possible structures, and the real structure is hybrid of all these structures, that is called resonance canonical forms. Look at the O3 possible structures. The real structure of O3 is hybrid of these two. The possibility of resonance will always increase the stability of molecule. The real structure is hybrid of all canonical forms. Look at the carbonate ion structure, which we discussed. So you read up to this point. Okay? You have to read 3-4 times. If you don't read, God cannot help you. God helps those who help themselves. So you please help Allah to help you. You read up to 4.3.5, 3-4 times. If you read it thoroughly, you get clarity. If you have doubts, you ask me. You can ask me 100 times. I will explain 101 times. I will also try to make YouTube videos. So think that I am your friend, philosopher, and guide. And please understand, my dream is to see all of you as doctors. And also I am telling you, I will not pay you your consultation fees when you are becoming doctor. If I am alive, I take free treatment from you. Okay? Are you prepared to give me free treatment, sir? If you are doctors, if you are in engineering stream, I don't expect any service from you. You are in engineering stream, so I expect you to join in IIT of your choice. That is possible only when you read the NCERT thoroughly, do all problems in exemplar. You are going to be future engineers from IIT, provided if you follow the guideline I am giving. Do follow this. For IIT means NCERT book and exemplar. For advanced, you require more information which we provide. Once you are